So let's talk about how to read a heat curve, its theory, some math behind it. So, does temperature stay the same or change when a phase change occurs? The answer is going to be stay the same. So, does the temperature change or stay the same when the phase stays the same? It's going to be the opposite. It's going to change. So in this case, we can identify that the phase transitions happen here and here. So these are phase transitions, because all of that energy is being used to transition all of those molecules from either a solid to a liquid or a liquid to a gas instead of raising their overall temperature. So then here, label phase transitions, it's going to be B and D. So then label where their states of matter are on the graph. So looking at this y-axis, we see that it's temperature. So is a higher temperature or a lower temperature going to be your solid, liquid, and vapor? In this case, we know that it's going to be solid at a lower temperature, liquid at a higher temperature, and gas at its highest temperature. So then label our boiling point. Our boiling point is going to occur at a higher temperature than our melting point. So in this case, we can just make our long lines, and this is how we identify our heat curve information. So using this information, let's apply it and do a little bit of math. So how much does the entropy change when converting 114 grams of solid methane to liquid CH4? So using our delta S fusion equation, we know that this is also going to be in joules per Kelvin. So plugging these values in, we know that it gives us our delta H over here. So I'm going to plug and chug this to my 0.942 kilojoules per mole over my K. So in this case, I need to identify, am I moving from a solid to a liquid or a liquid to a gas? In this case, I know that I have solid and liquid. So using my melting point temperature here, my melting point temperature is going to be negative 182. It says my temperature is in Celsius though. So I have negative 182 Celsius plus 273 because I want to be able to get to my Kelvin. My Kelvin is what it's specifically asking for. So this is going to give me 0.01035 kilojoules per mole of Kelvin. But in this case, I know that I need joules per Kelvin, so I see that I have moles on the bottom. I'm going to convert my 114 grams to moles using my molecular mass that it gives me over here. So I have 1 mole is 16.04 grams. So I have 7.107 moles. So then using this original value of 0.01035 kilojoules per mole times Kelvin, I'm going to multiply by my 7.107 moles. This is going to cancel out the moles, but I know that I want joules as well. So my dimensional analysis, 1 kilojoules is 1,000 joules. These cancel, and my overall value is going to be 73.56 joules per Kelvin based on my heat